All right, welcome back, everybody. Today we will be working with sixth grade math, and we're going to be focusing on one variable expressions and equations. Now, before I even begin, okay, just want you guys to know the difference because it's something that's crazy at all levels of math. It's frustrating. You will be asked in your state exam to enter an expression or equation. They look very similar. There's one key thing that's different. An expression is basically a bunch of terms that has either numbers or letters, k variables, that are split up by a plus or a minus. Okay, so like 2x plus 4 minus 3. Okay, equations are very special because it's going to be 2x plus 3 equals 10. So what makes it an equation? The equal sign. The reason I'm so frustrated and making a big deal out of this, so for you remember, try to be dramatic when I want you to remember stuff, is that if it asks you to enter an equation and you don't put an equal sign, you are automatically wrong. You can get everything else perfect, but if you forgot the equal sign, and so many students do, then you're automatically wrong. There's like no point, okay? So I have my own habits with this. Okay, I have my own little ways to kind of make sure we have everything that we need. So if you like that, hopefully, you can stick with it. If not, just figure it out. Okay, whatever helps you remember. You got to put an equal sign. Anyways, just big deal. All right. Okay. So select all, and if there's 4, I'm gonna pick 2 or 3. Can't pick one. It'd be multiple choice, and it's super rare to pick all of them. All of the equations that have an x equals 4 as a solution, that means x equals 4 will work. So, does 4 times 4 equal 8? No. Is 8 divided by 4 2? Yes. Is 6 plus 4 10? Yes. Is 4 plus 4 44? No, it is 8. So there we go. We ended up with 2 out of the 4, so not bad. So Alex went to the mall and spent some money on clothes. He then spent $16 at the food court. So notice I'm circling numbers. Altogether, does that sound familiar? What is that? What symbol could you say with altogether? He spent $74. Enter an equation. Boom, right there. Equal sign. That represents the number of dollars. So notice they use the letter C for dollars. I wonder why. That's weird. Okay. That was spent, on clothes. Okay, that makes more sense. All right. So where do you see clothes? Oh, I see clothes right here. So let's see. What do you have that's important? I have C for clothes. I have a 16. I have a 74. And I have an equal sign. Okay, so those are the things that stood out to me. Now, let me try to go with this in order, because that's usually what helps to figure out where things go and see how things line up. So Alex went to the mall and spent some money. That money was C. Okay, so there's my C. He then spent $16. So what do you think you're going to do with the 16? Are you going to add, subtract, multiply, or divide? You're going to add another $16 at the food court. Altogether, he spent $74. So altogether means that's going to be a total of 74. So let's look. Did I use all the things I have? I used the C. I used the 16, 74, and equal sign. So I think I'm happy with this. C plus 16 equals $74. Now, the thing that's crazy about these is that... is that you guys might have a different equation, which is totally fine. Maybe some of you guys said, you know what, I got 16 plus C equals 74. That's okay. Some of you guys might have said 74 equals C plus 16. That's okay. So any equivalent equation it should count for your exam. Okay, so if you didn't write it exactly like mine, it's okay as long as you wrote it similarly. All right, so now enter the amount of money spent on clothes represented by the letter C. So why are they asking for a letter C? In other words, I have to solve the equation. Okay. So if I have C plus 16 equals 74, it's like saying, how much money did I spend to get to $74 before I spent the 16? So 16 plus what is 74, essentially, right? So the idea is, well, if I had $74, can I take away $16? So if I do that, I'm going to say, okay, carry the bar of the 1, and I'm going to have 8 and 5. So let's see if that works. $58 plus 16 equals 74. Is that correct? Let me double check. 58 plus 16, so 8 plus 6 is 4, 1. 1 plus 5 is 6, and then 7. Yes. So this person, does it say who? Alex spent 50. No, see, I even wrote it wrong. Wow. Another simple mistake for us. So Alex spent $58 on clothes and then $16 at the food court for a total of 74. Okay, that makes sense. The difference between 23 and W is equal to 15. So this is in order. Look, I got 23 and W. And difference means minus. W is equal to 15. So this is where it gets a little weird. So should it be a plus or a minus? What's the difference? So it's supposed to be 23 minus W is equal to 15. And this one has to be written exactly like this. Okay? Because it is in order. You can't switch the W and the 23. It's not going to work. All right? Number 4. There's a lot of two-part questions here I'm noticing. Okay. Savannah is creating a Spotify playlist for the road trip she's taking during break. She already has 15 songs. So already has 15 songs on the playlist. And has to add S number. So there's another one. S amount of songs until she gets a total of 42. Enter an equation that represents the number of songs S that she has to add to reach 42. So what did I circle? I circled 15. I have to add something. Then I have an S. Then I have an equal sign and a 42. And that's, I think, it. So let's start from the beginning. So she already has 15 songs. She has to add S amount of songs until she gets a total of 42. Okay, it's not that horrible, right? It's pretty straightforward. Did I get the 15? Yes. My plus, my S. It's almost literally in order, which is kind of nice. Okay, so I got 15 plus S equals 42. Enter the number of songs that she added. So now I got to solve for the S. So how do I get there? 15 plus what is 42? This is where my Common Core comes in. Okay, this is how I do basically in my head, right? Like, how do I get to 42? Well, if I do 15 plus 5, that's 20. And then how do you get from 20 to 42? I just add 22. So 22 plus 5 is 27. Which is kind of crazy, right? A lot of people are bad on Common Core, but that's kind of how we do it in our heads, all right? A lot of mental math like that. All right, the sum between H, so sum means add, between H and 36 is equal to 75. It's already in order for us. So H plus 36 is equal to 75. Boom, done. Okay, awesome. Number 6, you went to Six Flags with your friends. You spent X, see your letter, amount of money on useless stuff and games. Yeah, because you know you're never going to use that stuff again anyways. But it was fun while you were there, I guess. Your friend spent 4 times as much. So that's 4 times. Like, I got to multiply something as you did. Wow, that's a lot. Your friend spent a total, that means equals, of $156. There's your equation. So you better put an equal sign. So let's see. I have to have an X. I have to have a 4. I have to multiply. That's what it means, right? Multiply. Excuse me. An equal sign and 156. So you spent, let's start at the beginning. You spent X amount of dollars. Your friends spent 4 times more. Did you have to add that? Does it say to add it anywhere? No. So your friends, now we're in a different part, right? Like, it doesn't say you added it to your friends. It just says now you're dealing with your friends. So your friends spent 4 times as much as you did. Your friends, so I'm still talking about my friends, spent a total of $156. So enter the equation that represents the amount of money you spent. So you are X in relationship to your friends. And your friends don't have a letter, so I think I'm okay. So you should have put 4X equals 156. Enter the amount of money you spent at Six Flags. So how did I get to 156? Wow. So the idea is 4 times what is 156? Well, normally we would just divide, right? Let me give you a simple example. 2 times what equals 10? Well, in order to figure that out, we would just say 10 divided by 2, no? Because most of us would say, yeah, it's 5, Beltran. Well, how did I get 5? It's 10 divided by 2. So if I use the same strategy, I can say 156 divided by 4. So let's see. 4 goes into 15 3 times. That gives me 12. Subtract them and I get 3. Bring down the 6, and that's 9. 36, and that's 0. So 4 times 39 equals 156. So here's the kicker. How much money did you spend? You spent $39. Let's make sense of this. So you, $39. Friends, 156. So does that make sense, the answer? So let's think about it. Mine was like $40. Theirs was like 160. So yeah, that's times 4. They spent way more than I did because, again, there were probably more of them. Okay? All right, moving on. The product, that means you are multiplying, of 9 and m is equal to 54. Okay, sweet. 9 times m is equal to 54. But it's weird to put an x, but it means multiplication. You know how that's where it gets weird, right, with variables. So I'm just going to leave it as 9m equals 54. Consider the inequality x is greater than or equal to -4. Determine whether each x values makes inequality true. So here we go again. Well, if you've seen the other videos, I'm going to graph this. It makes my life a lot easier. The setup takes longer, and you might be complaining, but it'll be way faster in the long run. I always promise you that. So my boundary point is -4. So boom, I'm just going to put it on the negative side. I don't care where, just in the negative. And that means it is a closed boundary point. So I got to count the -4 because of the equal sign. And it goes towards the right. So that means that all the values right here are going to make the statement true. Okay, the inequality true. So all we got to do is check each number. It's not a big deal. So where is -8? -8 is somewhere over there. Is that in my yellow area? No. Then let's go to 9. 9 is somewhere over there. Yeah, I don't care where, but it's on the right side. So that's automatic. Then I get -4. -4 is right there. Did that work? Yes, because -4 I can say is equal to -4. So that's true. -2. -2 is right there. Does that work? Yes. And then 0. Does 0 work? 0 is right there. Yes. So basically all of them, especially if they're positive, worked out. And then the negative numbers, they just had to be on the right side of the -4. Okay. Number 9. A construction company is building a rectangular pool in someone's backyard. Oh, isn't that nice? The length of the pool must be at least, okay, now I got numbers. So L has to be at least 24 feet. So what does that mean? Okay, well, I'll talk about it after. The width of the pool can be larger than 16 feet. Which pair of inequalities should the contractors be looking at for the dimensions? Okay, let's do one at a time. So for the L, has to be at least 24. So L equals 24. Can L be 25? Yeah. Can it be 26? Yeah. 27, etc. Right? So it has to be at least 24. So L has to be greater than or equal to 24. Do you see that? Because 25 is bigger, 26 is bigger if I put L, okay? What about the W? So the width can be, it didn't say it must, it can be larger than 16 feet. Okay, so if it can be larger than 16 feet, that means the W has to be 17, 18, 19, 20. So my W has to be bigger than 16. So which one of those options works? It looks like it's letter D. All right, here's another one that we've seen already. So let's see. And this gives me a hint, right? If I see it more than once, I'm like, pretty good odds, right? I'm not saying that's how it's going to be, but pretty good odds, right? It might show up for a few of you guys. So what did we do the last time? All we do is graph that. Let's just do a simple graph. We always put a 0. Where's our boundary point? Our boundary point is at -10, so that's somewhere in the negative area. It is going to be open because there's no equal sign, and it goes towards the left. So that means for me that all of this is okay. So let's check each one of our locations. -25, somewhere over there. Does that work? Yes. -15, that's somewhere right there. So yeah, that'll work. -10 is right here. Does that work? No, because it's open, so it does not work. It cannot equal 10. -10, it has to be less than -10. So -5 is over here, so that one is not in my area. And 0 also doesn't work, right? 0 is right there, so that doesn't work. All right. Next one. Oh, identify the graph that represents the solution. So this is where it's really nice. Guys, this has got to be an easy one for you, okay? The main thing is it open or closed? That should be open, and it makes their life easier because I can automatically get rid of the closed ones. So what's the next step? Well, I got to figure out what direction it goes. So in this case, since my X is first, or it's on the left, whatever direction it points is the direction it goes. So I'm going to be left at -2. Good. Right? All of those. But I have to go to the right. So in this case, it should be A. Number 12. Choose all sets of numbers that represent the solutions to the inequality m is greater than -1/4. So choose all. That means I'm going to pick 2 or 3. So 2 or 3. Okay. So let's make my number line. There's my 0. And there's my -1/4. So open, and it goes that way. All right. So let's check each one. -1, does that work? -1 is more than 1/4, so it's over here. Yeah, that's already wrong. Well, if -1 is wrong, can you see -3? Yeah, that's way over here, so that doesn't work. What about -1/4? -1/4 is also not going to work. So because it is not closed, so that one didn't work. And then we have -2/4. So that's over here. -3/4, that one also doesn't work. Oh my God. So what did I just say earlier? Well, in a bunch of other videos too. You're never ever gonna pick all four. Okay. Yeah, that didn't work. Oh, I know why. I am sorry. I see the mistake. I apologize. It is not. This is why I fixed it. Because it didn't work, right? And I told you guys it wouldn't. It is not negative 1/4. It is negative 5/4. Oops. Because that would help. Okay, I apologize. Sorry. I don't want to start the video over because I'm almost done. So let's just fix it. I just saw this on my printed copy here. All right. So negative 5/4. It's still open and it still goes to the right. Okay. So let's see how this will change things now. So if I have negative 5/4, notice my numerator is bigger. So this is technically over 1, right? It's more than 1 because 4/4 equals 1. So if I have 5/4, that means it's greater than 1. It's bigger. So that's negative 1 and change, okay? So let's try this again. Negative 1 technically is right there. That's negative 1. 0 is right there and 1 is right there. So this one does work. You see why I had to change it? Okay. All right. The next one. Let's see. I have negative 3. Okay, negative 3 is over here. That's already wrong. So I know that one doesn't work. Next one, negative 1/4. Okay, that one is right there. Okay, because it's less than 1. Then I have 0 and positive 1/4. So that one works. And then the last one is negative 2/4. Whoa, negative 2/4. Okay, is right there. Negative 3/4 is right there. And negative 4/4, I just saw that right there, is right there. You're getting closer to it, but you never touch the negative 5/4. So technically that would work as well. Whew. So there you go. That's why I had to fix it. And that's, as I tell my students, what happens when I make up my own problems. Sometimes it doesn't work out the way I want it to. Okay, so sorry about that little hiccup, but hopefully that made sense after. Okay. Number 13. Got the last two, right? Last two, yep. Some cities in the U.S. have sub-zero temperatures. The morning temperature in Juneau, Alaska will start at 3 below 0 and gradually rise throughout the day. Choose a number line that best represents the change in temperature. F, that will happen. Okay. So now you got to think about it, right? This is life. Like, what does it mean if it's 3 below 0? So notice my options. I have a 3, I have a negative 3, a negative 3, and a 3. So it's kind of like a 50-50, right? We can start there. Should you start at 3 or negative 3? What do you think it means to have 3 below 0? That means it has to be on the left side. It has to be a negative 3. So the last kicker is it has to rise. So if it rises, you're going to be at negative 3. It has to go up. What happens if your temperature goes up? Doesn't it mean that it gets hotter? So what direction gets hotter? Does it go to the right or to the left? So in this case, it should go to the right. Okay. Plus, if it rises, remember there's your plus and your minus. That direction means rise. If it lowers, it goes to the left. Okay. All right. And number 14, consider the inequality to, and it's the only one we get to use a calculator, so I am definitely going to use this. Always take advantage of that. So consider the inequality 2x is greater than x squared. Determine whether each value of x makes it true. So literally, anytime, and I tell this to all the students at all grade levels, like 90% of the time, 99% of the time, it feels like, if they say x equals, y equals, w equals a number, like they basically gave me an answer. So when they give me an answer, usually it means you plug it in, or you can, to figure stuff out. So that's kind of what we're going to do here, guys. Okay? So I'm going to do one at a time. I'm going to start with x equals 0. So 2x greater than x squared. And again, I'm going to change this to 0. So 2 times 0 is greater than 0 squared. And then that's 0 squared. You're like, what is that? Well, I have a calculator. Do you see that square button is my a to the 2? So if I put that, what did I do? Oh, that just gave me a 2. That didn't work. So how do I fix that? Let's start with the 0. And then if I press that 2, oh, now it looks nice. So 0 to the second power is 0. So what do I have here? Is 0 bigger than 0? No. And that's it. That's all we're doing. We're just checking each one. So now let's do 1/2. So 2 times 1/2 is greater than 1/2 to the power of 0. Oh, no, power 2, sorry. So let's see, calculator time. 2 times fraction 1/2, and I get 1. And then I have 1/2. Let me put it in parentheses. 1 divided by 2 to the power 2. And that gives me 0.25. Is 1 bigger than 0.25? Yes. Okay, yes it is. Next one. X equals 3. So 2 times 3 is bigger than 3 squared. So 2 times 3 is 6. Then I have 3 squared. That equals 9. Is 6 bigger than 9? No. Can you kind of tell the pattern already? Because now these 3's and the 4 and the 10 is getting bigger. So 2 times 4 is bigger than 4 squared. So that gives me 8 bigger than, what's 4 squared? 4 to the power 2. 16. Is 8 bigger than 16? No. And finally, the last one. I got 2 times 10 is bigger than 10 squared. So 2 times 10 is 20. Is 20 bigger than 10 to the power of 2? No. All right. So what do we learn here? Quick little summary, right? We get to see that number lines are important. Plugging in is important. Inequalities, you got to know what they mean, okay? So usually what happens is you got to know how to graph them. It helps a lot, like for number 10, number 8, number 11. The other ones with the equations, a lot of it is, can you label what information they gave you so that you don't forget anything? And of course, if they ask you to write an equation, please make sure you put an equal sign somewhere. That's your clue. If it does not say equation, if it says write an expression, like other quizzes will tell you, do not put an equal sign because they didn't ask for an equation. Just it goes either way, okay? All right, so until next time.